The next step in our discussion of functions is to think about what information we can acquire about a function given certain information. In this lecture, we're going to talk about getting information from the graph of a function. Then in the next lecture, we'll talk about getting information from the formula version of a function. So let me say up front, I ask you to just bear with me a little bit. This lecture and the next one are a little long. We're really only going to look at a couple of specific examples here, but there are a bunch of questions we can ask about it. All right, so that is going to make this a little longer than usual. So the most fundamental question we can ask about a graph is, does this represent a function at all? Right? We actually have a really simple method for doing that, based really strictly on the definition. It's got a name. It's called the vertical line test. And the idea is, if you can draw so much as one line, one vertical line that crosses the graph at more than one point, then the graph isn't a function. Because basically what we're doing is we're picking an x value and drawing a horizontal line through that x value, and the places where it crosses the graph are the corresponding y values. If we always get exactly one y value for each x value we pick, then the graph we're looking at does represent a function. Now, if we try that on the other hand, on the other one over here, if we pick, for example, x equals 2 and draw a vertical line, here that line crosses the graph at 2 points, right? So because there are two y values associated with that one x value, this is not a function. Remember, it only takes one. If I can find so much as one line that does that, then the answer is no. All right, so now we've got something a little more, well, not more complicated, but we've got a lot more questions to answer here. And I've graphed a function, and all we have is the graph, right? So we want to try to answer all of these questions based just on this picture. All right, well, first, is f a function? Well, based on our vertical line test, I'm going to say yes, it is. This is a function because draw any vertical line you like on there, and it's only going to cross the graph at 1 point. All right, so what are the intercepts of f? Remember, the intercepts are the places where the graph crosses one of the axes. So I can see the graph never comes all the way down here and crosses the x-axis. So I would say there are no x-intercepts. It does, however, cross the y-axis. And now here's the thing about working with graphs. They are inherently inexact, right? It looks to me like that is the point 0, 5, but I don't know. Could be 0, 5.1. Could be 0, 4.9. It's hard to tell from the resolution of the graph. So whenever we're answering these kinds of questions, just kind of have in the back of your mind, I'm going to say the y-intercept is 0, 5, but that's just an estimate, right? That's my best estimate based on what I can see from this level of detail. All right, so what are the domain and range of f? Well, the domain is all the x values, all the values, all the numbers on the x-axis that have a y value associated with them. So if I pick this one, for example, that's in the domain because that y value matches it. And if I pick another value over here and track that up, I'm going to come right up on the edge here, right? There you go. There is a y value associated with it. And because of these arrows here, right, the graph keeps going up and over indefinitely. So I can do that with any x value. Right? I can pick any number on the x-axis, start going up, and eventually I'm going to hit the graph. So my domain is all real numbers. Now the range is another story. The range is the y values. And there are some y values that don't have an x value associated with them. For example, if I come down here and pick something right in the middle here, right, that looks like it's about 2.5, right, and I do the same thing, I start going over to the side, I am never going to hit the graph. So y equals 2.5 is not part of the domain. Excuse me, is not part of the range. So the minimum y value is right here, right? It's at, again, we're estimating it to be 5. And if you pick any y value greater than that, and start going over to the right or the left, you will eventually hit the graph. So the range is going to be all numbers from 5 up to plus infinity. Okay, so for what values of x is f of x greater than 10? Okay, well, when you're looking at these things, f of x and y are the same thing, right? F of x is just another way of saying y. So this question is the same as asking when is y greater than 10? Okay, well, I don't know that this is inexact, right? But I'm asking about y values greater than 10. So it's all of these numbers up here. Okay, well, what x values correspond to those y values? If I go over here and then go straight down, that's about 2.5. So I'm going to say this point is 2.5 comma 10, and if I do the same thing going in the other direction, this is going to be negative 2.5 comma 10, and any x value to the right of 2.5 will give me an even bigger functional value, and any x value to the left of negative 2.5 will give me a greater functional value. So the answer to this question, I'm going to say, is everything from negative 2.5, starting at negative infinity over to negative 2.5. I'm going to leave that blank for just a second. Union 2.5 up to plus infinity. What do I want to put there? Do I want to put square brackets or parentheses? Well, notice here I have strictly greater than. So I do not want to include the x value that makes the function equal to 10. Those are my plus or minus 2.5. So I'm going to put parentheses at those inner endpoints. All right, and finally, is f of 5 positive or negative? Well, f of 5 is way over here to the right. And if I start at 5 and I go up and up and up, and it's going to be past what's drawn here, but remember that arrow indicates the function keeps going up. Sooner or later, this upward branch is going to meet my dashed line, and I don't know what number that's going to be, but I know that it's going to be a positive number, right? So f of 5 will be positive. So now we've got another example, right? I've got another graph here to work from. And notice this one is a little different. There are no arrows at the end of that curve, right? So we're going to assume based on that the function does start here, doesn't go past that value, and it ends here, right? Doesn't go beyond that one. All right, so now let's see if we can answer these questions. What are the intercepts of f? Well, I've got one y-intercept here, right? It looks like that's about 0, 0.5. Looks like it's about halfway up. And for the x-intercepts, all right, there's 3 of them. There's one here, that's negative 1, 0. There's a second one here at 2, 0, and a third one here at 4, 0. Okay, so how about the domain and range? Well, the function starts, just thinking about the x-axis, we're talking about the domain. The function starts here at -3 and it ends here at 6. Right, so I would say the domain of this is -3, 6. And we're the same thing with the y values. The smallest y value is -5, and the biggest y value is 4. So I would say the range is -5 up to 4. And I don't see open circles there, right? Absent an open circle, I'm going to assume that that the intent is that it does include those endpoints. All right, so question 3 here. For what values of x is f of x greater than 0? Well, remember, f of x, that's the same thing as y when we're doing graphs like this. So it's asking, where are the y values greater than 0? Well, the y values are greater than 0 in this section, and they're greater than 0 in this section. Now, we were asked about the y value, the x value. So the x values are from -1 to 1. And in the other section here, from 4 up to 5. Over to 5, really. Now, look at how I did those brackets, right? I did not include, oops, that should be -1, 2. I did not include -1 and 2 because the function is actually 0 there, and I wanted strictly greater than 0. I didn't include 4 for the same reason, but I did include 5. I did include this last endpoint because it looks like the point here is 5, 4, and the function is greater than 0 when x equals 5. All right, so one more. Is f of 3 positive or negative? Well, this 3 here, that's the x value, and f of 3 is the y value. So if I go over to x equals 3, I don't know exactly what that number is, but it's below the x-axis. Because it's below the x-axis, it's a negative value. So I'm going to say f of 3 is negative. Okay, so now we've seen how you can pull information from a graph, and this is something you'll sometimes possibly have to do. Journal articles, research articles, even business and professional publications. Sometimes a lot of the time, they won't provide the underlying data or the formula for a graph, even if there is one. Right, so you really, all you're given is a graph, this visual representation, and you have to be able to draw conclusions from it. All right, so in the next lecture, we're going to go the other way. Right, we're going to start with a formula, right, an algebraic expression, and we're going to see how we can take that and answer questions similar to the ones we looked at here.